All right, I'm going to prove that 1 plus x is less than or equal to e to the x for all x in R, and I'm going to prove that the equality holds if x is 0. Proof. All right. So we're going to do this in kind of 3 steps. I'm going to show something at 0, and then I'm going to show before it's decreasing. I'm going to show it hits 0, and then I'm going to show it's increasing. And so it's going to be, well, I'm going to construct a function such that the function is always greater than or equal to 0, essentially. So we're going to start that by, we want to construct our function. So I'm going to take the inequality, and I'm going to subtract that over, and I'm going to have that just be my function. So define h of x to be, let's see, e to the x minus 1 plus x. Okay. And now I'm going to check at 0. Note, h of 0 is, well, this is 1 minus 1. That would be 0. So we have 1 minus 1, which is 0. So h of 0 is 0, which is cool. And we want to check, let's see, let's take the derivative of h, a natural step, to find out stuff about decreasing and increasing. You should look at the derivative. So h prime of x is equal to e to the x. That minus sign would distribute there, so we just get minus 1. Minus 1. Okay. And now we want to consider when x is greater than 0 or x is less than 0, because if x is greater than 0, well, e is just like 2.7 something, so 2 point something minus 1 definitely gives me something that is positive. And if x is negative, then we'd have a fraction over here. So we'd have 1 over 2.7 minus 1, which is definitely smaller than 0, so that means something negative. So let's write this out. For x positive, h prime of x is positive, and for x negative, h prime of x is negative. Also, at, maybe we don't need to say, do we need to consider where h prime is 0? Let's think about that. That would tell us this would be 0, and so it would be constant there. Which I don't think is relevant, but we'll write it. Why not? H prime 0 is 0. Okay, so because we're going from negative to positive, all right, so actually because the derivative is decreasing, so, okay, since h prime 0 is I meant to do the other way, is negative for x less than 0, h of x is decreasing, or it's decreasing on negative x values, and at 0, h of x is 0 at 0, and h prime of x is positive for positive x's, so h of x is increasing. So if we think about what's going on graphically, we have a function that's decreasing until it hits 0, and then it's increasing. And so that function is always going to be greater than or equal to 0. So thus, h of x is always greater than or equal to 0. So we know h of x we define to be this. So we get e to the x minus 1 plus x greater than or equal to 0, which I'm going to add that over to get e to the x is greater than or equal to 1 plus x for all x, which is the condition we wanted to prove. And we kind of implicitly already showed equality holds at x equals 0, because we see that if we plug in, where is it? Yeah, h of 0 was 0, and so we just set this equal to 0, and then we solve, and then we see that 1 plus x is equal to e to the x. And so we have both conditions kind of implicitly proved in the proof, and we are finished. That's all.